This is the summary created from the video. Lecture 29 Demonstration XI. In this demonstration, we explore the concepts of multithreading in Java, including creating and executing threads using the thread class, and runnable interface, as well as methods for controlling threads, inter-thread communication, and synchronization. First, we create three threads, thread and threads, each printing a sequence of numbers, demonstrating how threads run concurrently alongside the main thread in a random order, resulting in interleaved output. Next, we implement the same problem using the runnable interface, creating thread-strex, thread, and threads, and observe similar interleaved execution when starting these threads. We then dive into accessing thread identities using the getId method, illustrating the unpredictable ordering of thread execution across different runs and comparing the implementation using runnable versus extending the thread class. Moving forward, we examine various thread states and control methods like yield stop and sleep, demonstrated through examples of parallel execution of tasks like sorting and searching, as well as the ability to suspend, resume, and assign priorities to threads for effective utilization of system resources. To understand thread priorities, we create three threads A, B, and C with loops printing numbers, and assign different priority levels max priority to thread 3, min priority to T1, and a random priority to 2, resulting in execution order based on these priorities. However, we also explore the potential data race condition that can occur in concurrent programs without proper synchronization, leading to non-atomic and inconsistent increments of shared variables, as demonstrated by a code example producing varying and erroneous outputs. To resolve this issue, we introduce synchronization techniques using a banking transaction example, where two threads T1 and 2 executed deposit and withdraw operations concurrently on the same account, showcasing how synchronization prevents data races by allowing only one thread to execute critical sections at a time. In conclusion, we highlight the benefits of multithreading for improving performance in parallel computing operations, while addressing challenges like race conditions through synchronization techniques, ensuring data integrity in practical applications such as managing banking transactions and exploring advanced concepts like thread priorities and states, predicting increased adoption of multithreading in the future. Please stay tuned for more summary videos.